Good morning and welcome to Coffee with Mr. V again. And today we're going to bring together some of the previous episodes that we did on short run costs and yesterday's episode on revenue, and look at profit and profit maximization. Now remember, in order to participate with Coffee with Mr. V, you need to go and grab yourself a coffee or go and get yourself any liquid, put it in a mug, a glass, a cup, or anything of your choosing. And then together we're going to do the synchronized sip, and that's going to be the best part of your day. So here we go. 1, 2, 3. I love coffee. So revenue minus costs equals accounting profit. If we're doing business studies, we just call it profit and leave it there. But because we're economists, we're a little bit weird. Okay, so we have accounting profit and we have something called economic profit, which I'll go into the difference between the two in a moment. Revenue, remember, is just P times Q, price times quantity. Costs then are total costs. Remember, we got total costs from adding fixed costs to variable costs. So total revenue minus total costs is accounting profit. And in any other walk of life, people would just ignore the word accounting and just call it profit. So if a firm makes, let's say, £1,000 worth of revenue, and it has £500 worth of costs. In fact, I'll make that slightly different just so the end result will be different. The accounting profit will be £400. It's that simple. But because we're economists and we like to do things a little bit differently, economics at its heart is just the study of alternatives, okay? So one of the first concepts that you were introduced to in kind of week 1 was that idea of opportunity cost. What else could you have done with your resources? What else could you have done with your time? What else could you have done with your money? So in this scenario, what we're considering is what other industry could the firm be in and how much profit would they have made from that? To find out economic profit then, we should be considering the opportunity cost, the profit that we could have made in another industry. So for example, if we made £1,000 revenue again, and we still had the £600 costs. So no change there, same as before. But now we also work out that we could have, if we'd have switched to a different industry, we could have actually made £300 profit in a different industry. We need to take that into account to work out economic profit. Well, 1,000 minus 600 minus 300 is still 100, positive 100. So it is still, according to economic theory, it is still worthless being in this industry because actually the 400 accounting profit is better than the 300 that we could have made somewhere else. So that's why we get the positive 100, okay? As long as this number is positive, what it's saying is that this producer, this entrepreneur should stick to this market. This is the best allocation for their resources because they wouldn't be able to make more profit somewhere else. As a kind of, the opposite of that would be when we work out that actually, if we'd been in a different industry, we could have made £500 profit. Now, if we do the maths, £100, £1,000 revenue, £600 total costs, minus an opportunity cost of 500, the money we could have made somewhere else, you'll see that we get a negative 100. This is a signal to us as a producer to leave the market and go and do something else. Go and put your resources, go and reallocate your resources into this industry, because this industry we were making 500, whereas back in the other industry we're making 400. So it's time to leave, time to reallocate the resources somewhere else. So that's why we have the economic profit, okay? Anyway, let's bring this all onto a diagram. So I can't remember the episode now. I think it was probably back in episode 1, we were doing short run cost curves. And then last episode, episode 6, we were doing revenue curves, average revenue, marginal revenue, and we also did total revenue. Well, I've got a standard downward sloping demand curve, all right? And now I've got labeled axes. We've got the marginal revenue curve, which is twice the gradient of average revenue. And I showed you the maths for that in the previous episode, episode 6. So to find out things like profit and how much profit a firm is making, what you need now is some cost curves. Well, that's good because we've done the cost curves already. We know that marginal cost, for example, is Nike swoosh shaped. Now I'm going to pause there for a moment, because one thing we can already tell now, and theory of the firm is all about predicting the behavior of firms. What are firms likely to do in a market? Well, we can tell now from this data that a firm is likely to produce at Q1, where MC equals MR. MC equals MR. Easy way to remember it, Mr. equals Missy. Okay, this is a fundamental rule of theory of the firm. It's called the profit maximizing rule, or the profit maximizing level of output. Okay, I'll just leave it as profit max for now. Why is it the profit maximizing level of output? Well, marginal cost, remember, is the cost of making each additional unit. Marginal revenue is the revenue received from selling each additional unit. Prior to Q1, marginal revenue is larger than marginal cost. Okay, so I'll write that here. Okay, before Q1, marginal revenue is bigger than marginal cost, and therefore there would be an accumulation of profit. Profit would be going up, profit would be increasing. After Q1 then, notice that now MC is bigger than MR, or MR is smaller than MC. The two have reversed because that's the crossing point. Okay, so before that, MR was bigger than MC, now MC is bigger than MR, which means for every additional unit that's produced, the cost of making it exceeds the revenue we get from it from selling it. And therefore, we would actually see a decrease in the total amount of profit being made. That's not to say that there wouldn't be any profit, it's just that profit isn't maximized. And in fact, if I draw very quickly a kind of profit graph above this, I haven't given myself quite enough room, obviously didn't think about this very well. What we'd see, if I was drawing a profit line, I would see my profits increasing to a maximum here, okay, and then falling off down there. This would be total profit. So total profit is positive all the way along here, provided, well, we'll show in a minute, average costs are lower than average revenue, but they peak at Q1 where MC equals MR. So MC tells you what you need to know in terms of output. Then we can draw up to the AR line, which is the demand curve, and that will tell us what price we can charge. Because remember, the demand curve shows us what consumers are willing and able to pay for any given level of output. Well, we know that now we're producing Q, so we know that producers will pay P, so that is the selling price. And indeed, we can work out total revenue now because we have P and Q. All right, so we've already got our total revenue right there. Okay, we've got total revenue, P times Q. What we need to find out now then is total costs if we're going to find profit. To find total costs then, we'd use an average cost curve. You'll remember from episode 1, the average cost curve is a smiley face, okay, with the minimum point that intersects MC. If you want clarification on that, I suggest you go back to episode 1. So I'm not really aiming for any particular point here. I just need to make sure that it's a smiley face and the minimum point goes through the MC curve. So there we go. That will do. There's my short run average cost curve. To find total costs then, we know that we're producing at Q1. We know we're producing at Q1 because of this rule. We'll read up now from Q1 to the average cost curve, and we'll read across there, and that'll give us our kind of average cost per unit. But of course, now we can find total costs because we've got average cost per unit times the quantity. That gives us our total costs. So just to clarify, just to go back one, let's make this green box here total revenue, and let's make this red box here total cost. We now have revenue minus costs, and therefore that shaded area there, I'm just going to grab a different color pen, probably put it in orange. Okay, that rectangle there is the accounting profit. Now, say it's the accounting profit. But the truth is, in theory of the firm, and this is the one area, okay, this is the one area that I actually think there's a bit of a hole in the theory, because we've worked out accounting profit here, but the theory tells us that it's actually economic profit. The idea is that the opportunity cost has somehow been baked into our the way in which our average cost was formulated. Now, of course, it hasn't, and I think this is a bit of a fudge of the theory to make it work. But we are told that we need to interpret that shaded orange area as positive economic profit or supernormal profit. Okay. Now, I am very happy for some of you to go out and find other people who might try and clarify that. Okay. I've never met anybody who can explain to me exactly how the opportunity cost is baked into average cost. I genuinely think it's a hole in the theory, but be my guest. Please go out there and ask people around you what the answer to that question is, if they know. Okay, so we have managed to derive profit or supernormal profit from our revenue and cost curve. And if you get the question about drawing a cost revenue diagram, that's what it means, cost revenue diagrams. Okay, now a couple of other scenarios just to finish off. Okay, always draw these the same way, by the way. Okay, always draw the AR curve in first, the demand curve, because once you've done AR, you know what MR looks like. It's always twice the gradient. You always know that the MC curve is a Nike swoosh shape, so that should always be the third line that you draw, and always put Q1 in there. If you do that, you won't make a mistake later on. Draw up to P1, and there is your total revenue. Now, you may have a scenario in which average cost is lying somewhere up here. Okay, well, the analysis doesn't change. We still draw up from Q1 to hit the average cost curve, and that gives us our average cost there. And then we would shade in that area, but that's no longer profit. Average costs are higher than average revenue. So that would be saying that whatever the total costs here are bigger than the total revenue, and actually we'd be making a loss. Okay, so this is a loss-making firm, and this is a supernormal profit-making firm. Another scenario then, and this is probably the trickiest diagram that you're going to have to draw in the entire course, the monopolistic competition in the long run diagram. That's to skip ahead slightly. Okay, again, note how I'm always drawing this the same way. AR, MR, MC, put Q1 in, draw up to the demand curve, put P1 in. And now if I put an AC curve here, all right, it's still smiley faced. It's still got its minimum point going through the MC curve. But what you notice is that when I draw up from Q1 to AC, it's the same as P1. So actually my total revenue equals my total costs and my profit equals 0. Again, just to clarify, apparently the opportunity cost is already baked into these diagrams. So it's economic profit of 0, normal profit, okay? That is the minimum amount of money required for a firm to stay in the market. In this scenario, okay, if they were to lose £1 more, that would be a signal to leave the market and go into another industry. But whilst we're making normal profit, economics says you should stay in this market. You have the optimum allocation of resources. And to think about it in the real world, by the way, some students always find this a bit weird. They think, well, break-even's rubbish. Break-even is not necessarily anything to be scared of. With break-even, you still get to pay off all your costs, and that potentially includes your salary, okay? So don't worry about this not making any sense. I mean, a lot of students think, but all firms aim to make profit. They are aiming to make profit, okay? But remember, economic profit of 0 doesn't mean accounting profit of 0, okay? It still means you're making accounting profit, and it still means you get paid, right? So hopefully that now makes a little bit more sense about the profit maximization, how you find it and how you find profit. And the analysis of the diagrams, by the way, is the same regardless of the market structure. The market structure lines themselves, as we'll see in future episodes, do change, but the analysis is still the same. You still need to find MC equals MR. You still need to draw up to the AR curve to find the price. You still need to draw up to the AC curve to find the costs, and the difference in between is either supernormal profit, a loss, or a normal profit, and it'll be one of those three. Fine. Very quickly then, there weren't too many questions from yesterday, but just as a point of clarification, somebody was asking about what would happen if the demand curve shifts. All right. So there we go. Demand equals AR, and obviously there's my MR curve with twice the gradient, and then AR shifts out that way. Well, MR and AR move up from the same point because when the quantity is 1, it's both the margin revenue and the average revenue, but it would still have twice the gradient. So the relationship between AR and MR doesn't change. If we're talking about total revenue then, remember total revenue is the integral of MR, or MR is the derivative of TR. That is the revenue maximizing point. Okay, that's the point where PD equals 1. Until that point, revenue will be increasing, albeit at a decreasing rate. And then after that point, it will be decreasing, and it will cut the Q-axis when AR equals 0 down here. Okay, if the demand curve changes, then all that happens is that the total revenue curve is kind of elongated, it's kind of stretched out along that Q-axis, and it will also go higher because the total revenue will also be higher. But look, here we go. Here's our new MR equals 0. So that would be my new peak. The fact that the demand is bigger, so that revenue there is bigger than that revenue that's there. So it will be simply up here, and then same idea, it will then fall like that. I mean, actually thinking about it now, as I do this video, that would make quite a neat question in an exam paper to kind of give you some diagrams and ask you to adapt them, given the fact that the demand curve might change. Somebody also wanted me to clarify the point about PED changing along the line. I will do PED and all the elasticities in a future episode. But the reason that elasticity changes along the line is simply because of the mathematical formula that we use to calculate elasticity. It's a percentage change rather than a calculation of the gradient. So it is true that, I better get this the right way around, it is true that for all, lost my train of thought for a moment. For all numbers down here, quantity change from 1 to 2, that's a big percentage change. So that will be a large numerator and a relatively small denominator. So it is true that they will all be relatively elastic down up there. And down here, when the price changes are very high, 1 to 2, again, being quite a large price change, but in percentage terms, not necessarily a big change with the quantity there, they would be inelastic. Now, that is true regardless of the good. So even if you're talking about oil or, I don't know, something like heroin, which is we talk about it being very PED inelastic, and indeed we draw it, like that, okay, we draw it steeply to represent the fact that it's inelastic. It would still be true that halfway along there, it would have a PED of -1, and it would still be relatively elastic up here. But you'll notice, look, the -1 is much higher up the p-axis than it would have been down here. And similarly, for something that is very elastic, okay, even though we draw it kind of relatively shallow, it will still have the price elasticity changes along it. It is there's no real kind of interesting story or fun tale that I can tell you about that. It's a manifestation of the mathematical formulae behind it. Okay, so elasticities do move along the line, and as a result of that, that's why you get these kind of peaks in total revenue, because of those relationships that we talked about before. When you're elastic and you increase the price, you'll lose revenue. But if you decrease the price, you'll increase revenue. So as you come down here, look, as we come along here, we're coming down the elastic bit, we'll increase our revenue. But once we keep going down here and down the inelastic bit, and we decrease the price, we'll see also a decrease in revenue, and you get the right-hand side of the total revenue curve. Right, I hope that kind of made sense. I realized I was talking quite fast there towards the end. But if you do have any questions, by all means get in touch with me and put some comments at the end of this video so that I know what I need to be doing in the next episode. All right, thank you very much for your time. Stay safe, guys. Keep drinking coffee, and I'll see you tomorrow. Bye.